Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video, well, I've got into a little discussion with some people about machine learning and analysing random data that you're taking out of your processes, and I'm saying, well, why don't you do a DOE? And everybody's going, what's a DOE? And why don't you just use high-powered software to answer the question? So this is a little video just to talk about what DOE potentially is and how it works differently to just collecting random data. So I'm going to just look at the idea of various variables, inputs, settings to your machine, which are having an effect on a result. So we're just going to consider a process. So we're going to go, this is DOE. This is DOE versus, I'm going to call it random data collection. Okay. You can do this if you want, but what I'm saying is you will get confounding patterns in this and you will get a problem. So we're going to go DOE versus random data collection. So okay, let's consider a process. Look. Yeah, so it doesn't really matter what it is. We are going to consider it a machine now, because people are talking about machine learning and they think you ought to just use high-powered software to just learn from randomly collected data sets. So we're going to make money, okay, and we're going to play with time, temperature, and pressure. So I'm going to keep it simple. We're only going to talk about three variables, and we're going to say that coming out of here, let's say whatever you're trying to make, we're trying to hit, let's just say we're trying to hit a hardness value. To be honest, you'd probably be trying to hit other things as well, so it'd be multiple outputs for multiple inputs, but we're just going to keep it simple, just to explain to the guys who love this, why don't you just use this in your machine learning? You just learn 10 times faster. I don't understand why you wouldn't want to do this. You know, work smarter, not harder. I don't want to spend £1 million on a piece of software. I just want to put the right data in some cheap, simple software that gets me the answer. So think now that maybe we'll go, let's have a look. Let's say there's 50 choices on time, 50 choices on temperature, and 50 choices for pressure. So we're just going to put those numbers in just to make a point about how you might test and what machine learning might do, what randomly collected data might do. Okay. So look, let's just consider this as a one-factor problem. Okay, so we have time. We can go anywhere from 1 to 50 on a particular setting. And of course, what we want to try and understand is hardness. Now, of course, we can do some tests. We can do a one-factor test. Maybe test along this continuum like this. And we get some data. We understand what time does. Okay, it's a way. But look, did you really need all of that data? Why did we collect all of that data? You know, we might have tested at all 50 places if we wanted to go really crazy. You know, there's just a model there. If you wanted to create that model, where did we really need to go? Well, to be quite honest, if we'd have gone this end and we'd have gone this end, then put the line in to model what was going on, and then done one test to confirm it at the midpoint, we could have got the same answer with just 2 tests. This is the point I'm making. We'd set the computer up to do just 2 tests to generate the model and then test in the middle. The computer would get the answer faster than fast could be. That's just one variable. Now imagine we got temperature, we got pressure. Now we could do the same sort of thing. But what you're doing, just think about this. It's very simple what we're saying here. A DOE pattern, look, is this. We've tested what we would call the low position and the high position for time. We're going to do the same for temperature and we're going to do the same for pressure. But if we do it in a special pattern, we'll get the answer very, very fast. And here's how you do it. Time was tested low and high. But at the same time, temperature was tested low and high. So time, low and high, temperature, low and high. So for these two, look, we've only tested in 4 places, even though if you multiply these two combinations together, what do you get? Well, if you multiply time with temperature, what you get, of course, is there's 2,500 combinations. I've just tested the 4 extreme combinations, then your powerful software will fill the box with maths. This is the point I'm making. If you go at this randomly, you'll do maybe 1,000 of these. Why would you want to do that? When if you test the right 4, then let your computer run, it gives you the answer. This is the pattern that you collect the data, and it makes sure that the whole thing works faster, 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 cheaper, 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 easier. Why wouldn't you use this? Now let's throw pressure in there. There we go, backwards like this, look. So now we got these points at the back. So that's pressure. Low and high. So what you've got, look, are these 8 points. Now if I put pressure into the calculation, so what have we got? 50 times 50 times 50. What have I got? This times 50, what's that? It's 125 with a naught on the end. 125, 12. Okay, so look, for these 3 variables, look, there are 125,000 possible places you could test. Now, I could just let a technician play with that design space, and what they would do is they would just randomly collect data. And I'm assuming, by the way, that they'd go all the way over the design space. There might be areas that they might decide they don't like. So there might be an area that is, oh no, don't go there. And so there might be areas that they never collect data in, but let's just assume that, you know, they just randomly collect data and then we go all over this design space. How many data points would you like to collect? There's 125,000. What are you going to do? Let him collect 1,000? Let him collect 10,000? Let him collect 20,000? Let him make loads of defects? Let him faff about? You know, why would you spend days and days, weeks and weeks, maybe months and months collecting all this nonsense when you know what you could do? You could just test the 8 corner points. 8 tests out of 125,000. Then you can give that data to Salford, to Minitab, to DOE Pro, to any simple regression software, and the regression that comes out of those 8 corner points will be brilliant, super accurate, works really well. I don't understand. You test the best 8 points, wouldn't you? There's no other way to do it. You can randomly test, but it's a waste of time and a waste of money, and you don't get good data that gives you good answers. So it's cheaper and it's better. I don't know, which technique would you use? DOE. This is why DOE versus random data collection. DOE is the best. Cheaper, faster, make more money, get more optimization, get a faster answer. Use DOE. Make more money.